This video covers Pre-Calc Notes 1.2. The first concept we're going to talk about in this video is finding the x and y intercepts of graphs. So here's what I know. I know that the x-intercept is when the y value is equal to 0, and I know that the y-intercept then, therefore, is when the x value is equal to 0. So if I have my equation, what I'm going to do to find the x-intercept is replace the y with a 0. So I'm going to rewrite the equation as 0 equals the square root of 2x plus 1, and then algebraically I can solve this for x. So I'll get rid of the square root by squaring both sides. And I'd still have 0 over here, but this would end up with 2x plus 1, because remember the square roots and the squareds cancel each other out. Move the 1 away by subtracting, and move the 2 away by dividing. So I'd find that the x-intercept would be negative 1/2. Make sure you take the time to write this as a coordinate point. So as an x comma y, it'd be negative 1/2 comma 0. Now finding the y-intercept, I'm going to replace the x value with 0 and solve. So if I rewrite this equation with a 0 for the x, it's going to look like that. And now all I have to do is solve underneath the radical here. So square root of 2 times 0 is 0. 0 plus 1 is 1. So I'd end up getting y to be equal to square root of 1, which is 1. And therefore, I would find my answer as a coordinate point would be 0, 1. So these would be my two answers. Make sure when you write your x and y intercepts that you're writing it as a coordinate point. So now if we do that again with a problem now that has an absolute value problem, absolute value bars involved in the problem, you have to make sure you understand how do you solve equations with absolute values in it. So again, we're going to replace a y with 0 to find the x-intercept, and then to find the y-intercept, we will replace the x value with 0. So in here, that's going to make it look like 0 equals negative absolute value of x plus 10. And here's how we have to remember when we solve absolute value problems. The rule is you write two equations. The first time you write the equation, you actually before I write the two equations, I made a very common mistake that a lot of students will make, is I didn't isolate the absolute value bars. So first thing is to isolate the absolute value bars. So right now what I have in front of here is really a negative 1. So to get rid of that, I'd want to go through and divide by negative 1. So now it's just the absolute value of x plus 10. And then to solve that, you would have to now write your two equations. So make sure if you have a number out in front of the absolute value bar, you get rid of it by dividing, in this case because it was being times by negative 1. So the first time I write the equation, I'm just going to get rid of the absolute value bars. So that would look like this. 0 equals x plus 10. And then remember the second equation that you write is when your answer, or your absolute value bars, is equal to the negative. So you'd set it up as negative 0 equals x plus 10. Well, understand that negative 0 doesn't exist, so you really don't have to solve this because it's the exact same thing. If this was any other number besides 0, you would get two different answers then for your problem. But because there is no negative 0, we're only going to get one answer of negative 10. So as a coordinate point, it would be negative 10 comma 0. If we go the other way and we replace the x value with a 0, y then would be equal to negative absolute value of 0 plus 10. 0 plus 10 is 10. The absolute value of 10 is 10, so now it's just going to be negative 10 is what y is equal to. And writing that as a coordinate point would be 0 comma negative 10. Alright, the next concept we're going to discuss is identifying where graphs are symmetrical. And so I've given you a chart here to help you figure out algebraically how do you show symmetry. It's very easy to look at a graph and see symmetry, but if I ask you to do it algebraically, you're going to do a couple different checks. So if you're going to check for x-axis symmetry, you've got to replace the y with a negative y. If you're going to check for y-axis symmetry, you're going to replace the x with a negative x. And then finally, if you're going to check for origin symmetry, you're going to replace both the x and the y with negative x and negative y. And when you do this, your goal is to be able to get back to the original equation. So let's write that at the top. So let's do the x-axis check. One thing I forgot to mention is that your graph cannot be symmetrical on the x-axis, y-axis, and the origin. It can be symmetrical on the x-axis, it can be symmetrical on the y-axis, or it's going to be symmetrical on both the x and y-axis, which is the origin then. So if you find that it's symmetrical on the x-axis, then you're good. You don't have to do the other three checks. So it's basically a guessing method. Pick which one you think is going to work and do that test. A good suggestion would be then to first look at the graph of it, and if the graph shows you a certain type of symmetry, then try that check. So if I was to look at the graph of this, I may want to try to start with the origin because I think that that's where it's going to be symmetrical. But if I don't see the graph of it, then I have to do all three checks until one works out. So let me show you how it would work with the x-axis check. So you're going to rewrite the equation where you change the y to a negative y. And now you need to algebraically solve this so you can get back to y equals x to the third. So if I want to get it to be a y equals, I get rid of the negative 1, and I end up with this. That was not my original equation, so therefore I know it's not symmetrical along the x-axis. So let's go to the next one. Let's try the y-axis symmetry. So I'm going to rewrite my original equation, but replace the x with a negative x. So y equals negative x, and then I have to cube that. Well, when I cube a negative x, I get negative x to the third. Again, that is not my original equation. So that means that it's not symmetrical along the y-axis. So by default, it should work out as being symmetrical along the origin if this graph is symmetrical at all. So you still have to do the check because you don't know for sure that it is symmetrical along that origin or not. So now what I'm going to do is replace both the x's and the y's with negative x's and y's. So it's going to be negative y, and then replace the x with a negative x and cube it. So this side's still going to be negative y, but this is going to be negative x to the third. And then I can get rid of the negative by dividing by negative 1, and what will happen here is that the negatives will cancel out and I'll just be left with y equals x to the third. Well, that is my original equation. So because I was able to get back to the original, then I know that it's symmetrical along the origin. So I'd want to write origin symmetry. So my suggestion to help you get started with these is to plug this into the graphing calculator and take a look at what the graph of that would look like. This graph would look something like this. So that would be a good indication that it is symmetrical along the origin here, so I should have started with that one. I didn't start with that one on purpose because I wanted to show you all three checks so you can see how they're done. If you know which one it's going to be symmetrical along by looking at the graph, then do that check. But you must show me algebraically the check. You can't just say x-axis or y-axis. You need to show the graphs. Okay, let's try the symmetry check again here. If I'm trying to look to see where this is symmetrical, if you have an x squared value, typically you're going to find that it's going to be symmetrical along the y-axis. Because if you plug in a negative x, you're going to get that to be squared and come right back to your original. So that's a good rule of thumb. Again, you can look at your graph and plug it into your graphing calculator. Your graph is going to look something like this. So we can see that if I was to fold my graph along the y-axis here, this blue part would overlap with the other blue part on the left side here. So in other words, if we fold it along the y-axis, that's where it would be symmetrical. So I'm going to try the y-axis check. And if I can get it back to the original equation, well, then I know that that's where the symmetry is. So it would be the y-axis check is replacing an x with a negative x. So it would be y equals 1 over negative x squared. Make sure you put the negative x in parentheses, and then add 1 to that. Well, when I take a negative x and I square it, it becomes positive. And that is my original equation. So because I was able to get back to my original, then I know that it's symmetry along the y-axis. And you might not always pick the right one right away, so if it didn't work out, then do the other check and see if it works out along the x-axis or see if it works out along the origin. But I think by looking at the fact that if the x value is squared, it's going to be symmetrical here. If you have a y value that is squared, it's typically going to be symmetrical along the x-axis. And then for the origin, you actually have to do the test for that one. And again, I would say look at the graph, and the graph is going to be very helpful to help you determine which one of these tests you should try. But again, when you do these problems, I want to see the check algebraically and not just, the answer, symmetry along this axis, or along the origin. I want to see the work involved with that. So you have to do more than just use your graphing calculator.